Good evening, everyone. First of all, thank you for taking your time and joining this session. I'm sorry we are delayed by 5 minutes. We had some network issues, and that's why we had to change the link and we started again. So, today in this webinar, we are going to talk about something that many beginners are actually scared of: CNC programming. When you first see a CNC code, it looks like some secret language, numbers, letters, symbols. And naturally, the first thought is, the difficult. I can't do this. This is very difficult. But let me tell you something very clearly. CNC programming is not difficult. It only looks difficult because nobody explains the structure properly. Today, I'm not going to overload you with too many codes. Instead, I will show you something more powerful: how to understand the CNC programming structure. I'm not telling about memorizing, I'm telling about understanding. No complicated theory. It is just understanding. And once you understand this, CNC programming will never feel difficult again. In the next hour or half, you'll be clearly understanding what a CNC program is, how is it structured, and how to read it step by step. And I'll also try to show some common mistakes because in real industry, small mistakes in program can lead to big problems. So stay till the end. This class will be very, very useful. Now, when beginners see the CNC code for the first time or the CNC program for the first time, it just looks like some random letters and numbers. G, M, X, Y, Z. Nothing looks similar. Nothing looks familiar. So naturally, they may feel that it is difficult. But again, I am telling you, CNC code is not complicated. It is just not understood properly. And once you understand the structure, everything becomes simple. Let's simplify everything in one line. A CNC program is nothing but instructions given to a machine. That's it. Move here, cut this, stop here. All these are written in the form of a codes. So instead of seeing it as something complex, start seeing it as instructions. Start seeing it as instructions. Now let me make it more simple or even more simple. Think let's compare CNC program as a recipe. So what's happening? If you want to cook something, you have to follow steps. You have to do it step by step by step. If you miss a step, the result will not be correct. Same thing happens in CNC. Each line in program is one step, and the machine simply follows those steps. So CNC programming is not about difficulty. It is so. Now let's think about this for a moment. You have a CNC machine in front of you. Hmm? It is powered on. Everything looks ready. But there is nothing. The machine will not move. It will not cut. It will not do anything. because the CNC it's own. Without the brain, the body cannot function. That is how important the CNC program is. So let's go to, so let's compare the CNC with a manual machine. In manual machine, what will happen? The operator controls everything. Hand movement, tool movement, cutting depth, everything depends on the skill of the operator. Now look at the CNC. In CNC, the program controls everything. Once the program is written correctly, the machine will repeat the same job again and again with high accuracy. This is the biggest difference in CNC and manual. So in CNC, your skill is not just operating the machine, your skill is in understanding the program. That is why learning program structure is very important. Now, you might be wondering, where do we actually write these programs? Directly into the machine controller. What we can do? We can directly come into the CNC machine. Or second option, we will use a computer, we will use a software, a CAM software, which can be SolidCAM, which can be MasterCAM, which can be Symmetron. Generate the program, and then this program will be transferred into the machine. In the real industry, both the methods are used. But for beginners, learning directly on the machine helps you understand better results. You write something instantly. The practical connection is very, very important. Now, at this point, some of you might be thinking, this here you have a CNC program, example CNC program I have. So some of you are thinking, this looks too much. How will I learn all this? Relax. You don't need to learn everything today. You don't need to memorize anything today. Your goal for today is simple. Just understand a structure. Once you understand how a CNC program is arranged, learning becomes very, very, very easy. Learning the codes becomes very, very easy later. So from the next slide onwards, we are going to take the same program, break it slowly, one by one line at a time, and by the end, you will treat a basic CNC program with confidence. So what it's again in this page, if you see, you can see that starting and ending, we have a percentage symbol. Then we have O1001, we have G21, the third line, fourth line, fifth line, sixth line. So we'll go through each of these lines and then explain you what these lines are. Now let's look slightly more realistic, okay? Compared to what this is a few more elements that we use in the industry. Now we are not going to learn everything here. We're just going to understand what is happening. Let's look it slowly. You can see the program starts with a percentage symbol, then a program number, then some setup codes. Then we have something new here. Tool change. This tells the machine to pick tool number one. After that, we have the spindle start. Then for the tool to start rotating, then the movement begins. And then we have the one important line, that is G43. Don't worry about this. We are all going to see this in detail. This Then we have the M08, M09 for coolant, G01, G02 for movement, M30 for programming. So normally, even though program looks bigger, it's the same setup. What is it? Start, setup, tool, spindle, movement, end. Start, setup, the tool will come. Before we start breaking the program, I want to clear one important thing. That's actually one important misconception many beginners have. That is, many beginners think CNC program is just some random codes written together. But that is not true. CNC programs are highly structured. Each and every line has a purpose, and each and every line comes in a sequence. It is not random at all. It is actually very organized. But the problem is, when you don't understand the structure, everything looks random. But once you understand the flow, you will start seeing order instead of confusion. So from now on, don't look to CNC codes as random letters. Look at it as a structured set of instructions. Let's go one level deeper. Each line in a CNC program is called a block, and each block give one instruction. The machine reads this program line by line. It does not jump, it does not skip. It executes exactly what has. If one line is wrong, machine will still follow it, and that is why mistakes happen. So always remember, machine does not think, machine only follows, and it follows exactly what you write. Here is the most important concept of today's session. So every CNC program follows a flow. I already told you earlier. The flow, this be it a simple program or a complex program, a small program or a long program, whichever it is, the flow remains the same. First, the program starts. Then the machine is prepared, that is, the setup is done. Then the tool is selected. Then the machining happens. And finally, the program ends. It's like a story: beginning, preparation, action, ending. So once you understand this flow, you can read any CNC program with confidence. Now, let's connect this idea to the program we saw. That program also follows the same structure. At the top, the program starts, then the setup codes define the machine condition, then the tool is selected, the spindle is start, then the movement command performs the machining, and finally the program ends. So, even though it looks like multiple lines, this is the key to understanding the CNC programs. Now here comes the most interesting part. We are going to take this same program and break it step by step. We will not rush, we will go slowly and understand what each line is doing. You don't need to remember codes. Just very first line, you saw the percentage symbol, right? You saw a percentage symbol. This symbol is used to mark the beginning and end. I think of it like opening and closing a file. It tells the machine program starts here, and then it tells program ends here. Now, in some machine, this may not be always visible, but in many controllers, it is used to clearly mention the program boundary. So whenever you see this symbol, don't get confused. It is just a mark with machining. It is just organizing the program. Now, next line, 01001. This is called the program number. You can think of it like a file name. In a CNC machine, there can be hundreds of programs stored. So each program needs a unique identity. That is why this number is used. In industry, if you select the wrong program number, you may machine the wrong part. So even though this looks simple, it is the most important in real applications. Now we come to a very important part, the setup line. Here you see the codes like G21, G17, G90, etc. Don't worry about memorizing this, just understand the purpose. These codes are setting the machine condition. They are telling the machine what units to use, which plane to work on, how to interpret positions. Before machining starts, machine must be in the correct condition. Otherwise, even if your movement is correct, the result will be wrong. So this line is like preparing the machine for the work. Let's understand one code from that line. So G21, this tells the machine that we are going to use millimeter as a unit. So imagine this situation, for example. You think your dimension is 50 mm, but the machine moves to a position x50 from the 0 point, not from the current position. This is very important for accuracy and repeatability. There is also another mode called incremental. But for now, just remember this idea, G90 is a fixed reference system and this helps maintain consistency in machine. Now, we move to a very important concept in CNC, that is the work offset. Here we saw the code G54. This is used to define this is wrong, everything will be wrong. So this is one of the most important concepts in CNC. So work offset is nothing but G54. It is a reference point with respect to the work. So if you have multiple works on the same bed, we can change it to 54, G55, G56, 57, 58, 59. Like that we can change it. Next is the tool selection. You can see the line, you have seen the line T01M06. The line T01M06. Let's break that simply. T01 means change the tool. So when this line is executed, the machine will automatically change the tool. So when this line is executed, the machine will automatically pick tool number. Many errors happen just because of wrong tool selection. Now the tool is selected, but it's not cutting it. Why? Because it is not rotating. So we need to start the spindle. So this is what this line does. What? Yes, 1200 means spindle with rotator speed of 1200 rpm. And M03 means spindle rotate in clockwise direction. So after this line, the tool will start rotating in clockwise direction at a speed of 1200 rotations per minute and is ready for cutting the work or remove metal from the work. Without spindle rotation, there is no machining. So this step is very important, and this is not a random number. We calculate it. You remember last class we had done a class about this calculations and everything. The same way, here we will calculate and find the spindle speed. Now, next is the important line G43H01. Don't worry about memorizing the code again, just understand the idea. In CNC, different tools will have different length. Some tools are long, some are short, and when you change a tool, the machine length. This is what this line does. It tells the machine the actual length of the tool. So the machine can position correctly. If this is not applied, what will happen? The tool may go too deep at all, or in worst case, it can even crash. So even though this looks like a small line, it is very critical for safe machine. Now we move into another important element, that is coolant. M08. M08 means the coolant is on. When machining happens, heat is generated and the chips are produced. So this coolant is used to reduce heat, improve tool life, and remove the chips. Now regarding coolant off. Then we have the movement. Movement. What is movement? This is where the actual machining happens. Till now, we had everything. Cell, clean tool, cell started, spindle, set offsets. Now the machine is ready. And now we tell the machine how to move. There are two main ways of movement, G00 and G01. What are these? Simple. G00 is fast movement without any cut. Like for example with the air. And G001 is the cutting movement. A movement where it will take the cutting and go. So one is for positioning and the other one is for machining. Let's understand both clearly. So G00. G00 is called the rapid turbo bed or the fast move. In simple terms, it moves the tool very fast from one position to another. But here is an important part. It does not cut material. It's only used to position the tool. Now imagine this before the cutting starts. The tool has to reach the correct location, right? We don't want the tool to slowly move all the way. That is wasted time. So we use G00 to quickly bring the tool near the job, but at a safer distance. Now, one important thing you should understand, because G00 movement moves very fast, it should be used very carefully. If the tool is too close to the workpiece or if the pathway is not safe, it can lead to collision. So in real machining, G00 is always used with awareness in simple for positioning and is not used for cutting. Now comes the most important movement, G01. G01 is the cutting movement. This is where the actual machining happens. When the tool touches the material and starts removing it, that is G01. Now this movement is controlled. It does not have to move the fast blindly. It moves at a defined speed, which we all call the free feed rate, because cutting requires control. If the tool moves too fast, it can break. If it's too slow, it can affect efficiency. So G01 ensures proper cutting happens every time. Now, I want you all to remember this clearly. Whenever you see G01 in a program, that is where the part is being created. Everything else is preparation, but G01 is where the real world applies. Let's combine both and understand the simple form. First, G00 is used. The tool moves quickly from its current position to the required location, and at this point, it is not touching the material. It is not moving into position. Now, once the tool is connected, it plays. G01 is used. Now, so G01 I told, G01 is used for the fast cutting, fast moving, and G01 is for the cutting. Okay. Now, let's simplify everything we have learned so far in one idea. CNC machining is not complicated, it is not magic, it is simple again and again in a proper sequence. And slowly, the final part is created. So, if you understand movement, you understand machining. And if you understand machining, CNC programming becomes very, very easy to learn. This is the shift I want you to make today. Don't see CNC as a complex code, see it as a control measure. Now, after the cutting is complete, we cannot just leave the tool inside the material. The tool must be moved away. The tool must be moved away safely. This is called retraction or going back to the home position, machine home position. The code we used here is G28 normally. So G00 is used to quickly move the tool away from the job. Now think about it practically. After machining, the tool is inside and very close to the workpiece. If you don't retract properly and directly move sideways, it may damage the part, it may damage the tool. So always the safest approach is first move the tool up. Then you can move to the any other axis. This is a very small step in program, but in real machining, safety depends on this. Now we come to the coolant on off. Earlier we saw coolant being turned on, that is M08. Now after machining is completed, coolant is turned off using M09. This is simple. The coolant is only needed during cutting. So once machining is done, there is no need to keep it running. So we switched it off. This helps in maintaining machine cleanliness and avoids unnecessary usage. Again, very simple line, but part of proper machining practice. Now we come to the final line of the program, the M30. This command tells the machine the program is complete. Once the M30 is executed, the machine stops, the program is reset, it goes back to the beginning. Now imagine if this line is missing, the machine may not behave as expected. So this line ensures CNC program must end correctly. Just like a proper beginning is important, proper ending is also important. Now let's look at the full picture. We started with the program beginning, then we set up the machine coordinates, then selected the tool, started the spindle, turned on the coolant, then movement commands controlled the machining. After that, tool was retracted safely, coolant was turned off, and finally program entered using M30. So if you look at the entire program, it follows a clear flow. Nothing random, everything has a place, and this is what I wanted to understand today. Now, here is the most important takeaway from today's session. Many beginners try to memorize the G codes. They try to remember everything, but that is not the right approach. Understanding is more important than memorizing. If you understand the structure, you can learn any CNC program. If you only memorize, you will get confused. So focus on understanding how the program works. Once that is clear, everything else becomes clear. Now, after seeing all of this, you might feel, okay, CNC is simple. And yes, the concept is simple, but here is the reality. Understanding basics is one thing. Do it on a real machine is another in the real industry. Don't just need read programs. You set tools, you set offsets, and small machines can create big problems. So the difference between knowing CNC and working on CNC coming from practical experience, and that is where most of the beginners struggle. Now the common problem. The common problem is many students codes, they know some M codes, they have seen the progress. But when they stand in front of a real machine, confidence is missing. Why? Because they have not practiced, because they have not seen how the machine behaves. They have not made mistakes and learned. And CNC is something you can learn only by doing. So, what do you actually need to become confident in CNC? Not just theory. You need practical training. You need to work on real machines. You need someone to guide step by step from basic to real job work. To understanding how industry works, this is how real learning happens. So now what you learned today is the foundation. Understanding the program structure is the first step. But in industry, this is not enough. The real demand is for people who can write programs, understand tool paths, handle real machine solutions, and um, this is where VMC programming comes in. So think of today's session like the starting point. The next step is learning how to actually create and run the programs. VMC program is where things become real. You are not just reading programs anymore. You are creating them. You decide how the tool moves, how the part is moved, how efficiently it is produced, and these are where the skills develop. And this is what industry is looking for because operators are many. Good programmers are always high in demand. So, in our VMC programming training, we focus completely on practical training. We will not just sit and listen. We will actually work on the machines. You will learn how to write the programs from scratch, how to set tools properly, how to handle offsets, how to run real jobs step by step. So by the end, you don't know CNC. It is not just that you don't know CNC. You are going to actually do working on it. Doing to program and then do the work. So if you're serious about learning CNC and building a career in this field, don't stop at basics. Take the next step. Learn the VMC programming properly with practical experience. Here at Open Education, we will guide you step by step from understanding to real machine confidence. And if you're interested, you can contact us and join the next batch. Thank you for being a part of this session.